Welcome everyone. We are going to do the tension test of metals today. This is a very important experiment because experiments 2, 3 and 4 are all tension tests of metals. So like I told you, this is our universal testing machine and it can be used to do a wide range of experiments. So first let us get started. Let us switch on the machine by pressing this button over here. And you can see the lights flashing on the handheld remote, and just wait a couple of seconds, let those lights be steady. Now let us go ahead and double click on TW Elite, which is the software which comes with the machine. So let it start, then we are going to get started with today's experiment. So once it starts, since today we are doing the tension test, so first step will be to go to File, click on Open Test and click on AEM 251 New Tension Test. So double click on that and it's going to load the tension test. Like I told you that all the experiments are already pre-programmed here, you just need to load them. Okay. So the experiment has been loaded and you can see that there are a lot of new displays which we are going to go into detail once we do the experiment. Okay, so once you have started the experiment, so your first task will be to clear all the previous tests which you have done. So just click on this and make sure that the tick is on, and right click on here and hit delete and delete all. So it's going to delete all your old tests so that there is no confusion. Okay. So once you have switched on the software and loaded the test, make sure that before you move on to start the experiment, make sure that the load is zeroed. Okay, so that will make sure that our load is accurate when we do the experiment. So let us go quickly to today's setup. So you can see that we have replaced the compilation platens which were here in the last experiment. And we are going to put the tension grips today, which we are going to use to do our experiment. Okay, so this is my tension grip. It goes on to this hole over here and fits exactly. So this tension grip, which you see over here, has a flat grip over here. Okay, now this has been specifically designed to handle flat specimens like this. Okay, so that it can be held very tightly over here. Now we have another type of specimen with the round edges. These are for fitting this kind of specimen you need different tensile grips. Okay, so these are the tensile grips with the flat heads. The other type which we have is the tensile test with the V grooves over here. So the V grooves are specifically designed to fit the cylindrical head of this type of specimens. It fits in like this. Okay. Now in this class, either you will be provided with the flat head specimen or with the round head specimen. Okay. So since we have both today, we are going to do it with the flat head specimen. Okay. Now your very first step will be to go ahead and attach the grips if they are not already attached. So in order to do that, I am going to go ahead and place it over here. And then I'm going to go ahead and take these pins and secure it into place. Make sure that the pin goes all the way, and once that is done, that means our specimen is fixed. Next, what I'm going to do is I'm going to go ahead and secure my grips by moving this clockwise and then tightening it with the help of this wrench. Okay, so use this panel and tight it. Similarly, we are going to place the other one over here. And what I'm going to do is again I'm going to go ahead and tight it. These are extremely heavy. Make sure you're extra careful while doing this. Okay, most of the time you're going to see that it's already attached for. So you can see this lever which moves. This will be used for tightening our specimen. Okay, so when I move this lever, you can see that this small bar over here, small metallic bar, when I move it, either it goes up to this surface or either it goes down. So when it goes up, that means the specimen is open. So whenever you are tightening your specimen, make sure that when you rotate the lever, this particular metal bar, it goes down. That indicates that we are tightening the grip on our specimen. Okay, so let me show you. So your very first step before you even do anything will be to go ahead and measure the specimen over here. So this is my 1/8 caliper, and what I'm going to do is I'm going to measure the cross section. So measure the cross section, it's 0.37 inches and this one is 0.13 inches. So make sure that you have recorded the cross section, because from the cross section you need to find out the area, and from the area you can find out basically we are going to use the area to evaluate stress. Okay, so once you have measured the area and everything, what you do is you can go ahead and secure your specimen by placing it over here and just go ahead and just secure it by tightening the grips. Okay, so like I told you, you can see that this metal bar is touching this surface over here instead of this surface. That means that it is securing my specimen. So now I can see that there is a considerable gap, so I need to bring the head down. Try to bring it down very slowly and carefully. So I'm just trying to bring it down so that there is enough room. Again, I don't want to keep too much room or too less room, so that this part is over here. So again, do the same thing. Go ahead and you can see that this metal bar is touching this surface over here. That means my grip is very. That means I'm tightening the grips. So my grips are now tightened. So next, what I'm going to do is I'm going to show you a different piece of equipment today, which is something new. This is known as a extensometer. So what it does is it measures strain. You can see that the extensometer moves, rather one of its limb is fixed and the other limb moves. Now the whole idea is whenever we do the tension test, we are essentially stretching we are pulling out the specimen apart. And the idea for the extensometer is it's going to fit to the specimen in such a way so that it drags along the specimen as it is being pulled apart. This will help us to measure the strain. Okay. Now the initial length within the knife edges of the extensometer is 1 inch, and so when it moves, it's going to give you the change of length. So change of length over length will give you strain. Okay. So take the extensometer and connect it very carefully. So what I'm going to do is I'm place the extensometer like this on the back, and there are metal grips, and make sure that the metal grip is over the center of the specimen over here, so that you can see that I have kept the specimen near the middle part of the small tiny flat section of the metal grip over here, so that it gives me optimal support, so that my data is more accurate. Okay, and this extensometer is prone to vibration, so make sure that it's fitted properly. Okay, so once I have placed the grip properly, that means my extensometer is secured. Next, what I'm going to do is I'm going to take my marker and I'm going to place 2 dots over here. Now this is just for visualization purpose. We won't use it for any calculations. Okay, so make sure that your grips are properly set up, and make sure that you put the 2 dots with the help of the marker. And so our extensometer is secure into place now. So before we start the experiment, let us quickly go over to the computer and see that what my displays are telling me. Okay, now let's switch to the computer. So if I see with the computer, I can see that the load is at 600, although I have not placed any load yet. So why is this so? So this is because we tightened the specimen very tightly, and this causes some residual load to build up. Okay, and it might also cause some residual stress. So when you do the analysis of the experiment, it's very, very important that you take care of the residual load, because initially the load on the specimen should be 0, and this is due to the way the experiment is set up, due to the tightening of the grips. So there is another video which I will post in the description box. You can see that if you click on that video is wholly dedicated on how you take care of this residual load. It's called the preload correction, and how you do the post-processing or the data analysis to plot your stress strain curve experimentally, which is the main purpose of our experiment. So don't get worried since the load is not 0. Don't worry about the cross-head. Next, let us go to the extensometer. Now, the extensometer should be 0. Why it should be 0? Because right now there is no strain, because I have not started my test. So although it's indicating a certain reading, that's basically a garbage reading. So we need to take care of it by right clicking on it and hitting the 0 signal. So once you hit the 0 signal, it's gonna be 0. So once that is done, everything is set up. Your next step will be to just start the experiment, and in order to do that, what you need to do is just go ahead and click this button and click it again, and make sure that this button is turned off, and make sure that when you come to the screen, you can see the play button over here. So if you press the button a couple of times, the play symbol will pop up eventually. So click on the play button, so that will cause the experiment to start. But there is a window which asks you a lot of things. Don't worry about it, just make sure that the extensometer gauge length is 1, because we are not worrying about it, because we will be doing the calculations manually, and there you have to take care of all these things manually, and that is a learning process. We don't want the computer to generate the stress strain curve for us. We want to do it ourselves from raw data, because that is something which we are learning in this class. So click OK, and the experiment will start. Okay. So once you start the experiment, make sure that one of you is with the computer, and one of you and all of you others are watching the experiment, and make sure that you are at a certain distance. One of you should be with the computer, because the computer will ask you in a minute to pause the test, and I'm going to tell you why when that moment comes. So the experiment has started. The head is moving up, and the specimen is being stretched out, or it's being pulled, and you can slowly see over here our neck will form. Okay. Initially, if you see the load versus deflection curve, it will be linear, and slowly it's going to transition to the nonlinear zone, and just wait for it a little bit. You can see that the necking will start. Okay. So now, like I told you, the computer has given me a pop-up asking me to take out the extensometer. So why is it so? So the extensometer has a certain limit beyond which it cannot be stretched. So the software has been designed in such a way to take off the extensometer, because we don't want to damage its limbs. Now, right now I've paused the experiment, so it's paused as was at this particular moment, and we can resume it anytime by hitting play. But before you do that, make sure you note down the extensometer reading. It's 0.0877 inches. This is extremely important, because this extensometer reading will act kind of like a marker to do the post processing. Okay. So what I'm going to do is I'm going to gently move these grips over here and take my extensometer off. So beyond this, we won't worry about the extensometer readings. Okay. I just want you guys to keep in mind is that the computer is slowly recording the data on the background, so you don't have to worry about that. Okay. So make sure you observe the center part of the specimen where eventually a neck will start, and I'm gonna go ahead and run this test again. So I have resumed the test. So the test, so again this specimen is being pulled apart, and slowly you can see that this zone will kind of neck. Okay, so it's gonna neck, and it's gonna get thinner and thinner, and the cross section over here will also get thinner, and eventually it's gonna fracture. So just wait a little bit and let the experiment happen. So you can see that this zone is getting thinner. It might not be that apparent initially, but it's gonna happen very fast. So please keep a watch on that. so we can see that it's getting thinner, and we can see that the specimen is still being stretched. So I can see that this part is getting like kind of forming a neck. So you guys again maintain a proper distance and make sure that you have safety glasses on. Okay, now the neck is getting more and more pronounced, and eventually it's gonna lead to fracture. So I can see that the neck is getting pronounced, and that's it. So once fracture has occurred, you can see a pop-up window on the computer screen. So it tells us that whether we want to return to 0 or not. So what does that mean? That means that the computer is asking me whether you want to return to the original position of the heads when we started the experiment. Now we have stretched out our specimen. We don't want to do that, or else the specimen will bend. So this is very, very important. Make sure you hit no. And once that is done, your next step will be to first go ahead and export your data. So this is basically your test data. Right click on it, go ahead and hit export, and then you can browse the location where you want to save. I want to save it in the desktop. Click OK, click OK again, click OK, and then it should create for you a folder in the desktop. Double click on that and make sure you can see the file. So the file does not make much sense to us right now, but we will explore this at a later time on how to use this file and get the experimental stress strain curve. So this is the raw data which was saved by the software. So we are going to process this raw data later on to find out the stress strain curve. So once you see that data, that means it's good. The data has been recorded by the computer. Our next step will be to slowly untie our specimen. So first I'm going to create a little bit more room over here by putting the head up. I'm just going to go ahead and untie my specimen, and similarly I'm going to do it for this one. So this is your specimen after the fracture. So you can see that the specimen has elongated by quite a bit. Okay. Now if you compare this to a new specimen on the side, you will see that the elongation is quite visible now. Okay. So now what you do is you take your vernier caliper once again and measure the cross-sectional area of the neck zone. Okay. So I'll measure the cross-sectional area by measuring the lengths, and that will kind of give you an idea of how much the area reduced by. Okay. So once you have done that and you have recorded all the data, so and you have the electronic data with you as well, so your specimen is already fractured. So now you can go ahead and press this button, and this experiment is done. Okay.